Hi, this video can tell you how to install the whole spectrum monitoring and direction finding system and start the software in the laptop computer. This is a laptop that can run the spectrum monitoring and direction finding software. It can communicate with the monitoring receiver through LAN interface. This monitoring receiver is the main device in this system. There are three cables to connect the monitoring receiver to the DF antenna. This is the top panel of the receiver. It has three cables connecting to the DF antenna directly. These are the controlling communication cable, the signal cable, and the GPS RF cable. And the DF antenna has electronic compass and GPS antenna inside. Besides the received spectrum data, all this information should be transmitted back to the receiver. On the right side of the receiver is the LAN cable and DC power supply for the receiver. For DF antenna, besides the DC power supply, there are totally 4 cables to the DF antenna. This kind of DF antenna can be mounted on a tripod or a vehicle using these brackets. Of course, it can be fixed in a station. To test the DF performance in the lab, we use a signal generator and a horn antenna to simulate the actual circumstance. The horn antenna is put on a tripod and points to the DF antenna. We use a signal generator to create the specific signals. After powering on the monitoring receiver and plugging in the DF antenna's power supply, we power on the laptop computer. After a while, we enter the desktop. We double-click the icon on the desktop and get the software running screen. Firstly, select the scan detection label in the main screen. Then, click Run button to start monitoring the spectrum by using the default configurations. You can see from the screen that the frequency span is from 88 MHz to 108 MHz. There are many FM radio channels in this area. Now, let us demodulate these signals and listen to the radio on the laptop. We turn on the marker and set the marker to a peak signal. We can drag the marker to a FM channel. Then, we can click Stop to halt the spectrum display. After selecting the audio demodulation label, input the dedicated frequency that we want to listen to. Then, we switch on the Run demodulation, and then we can listen to the sound. You can drag the shadow square to listen to different radio channels. Secondly, let us try to find the direction of the interference. We use the horn antenna to generate a 7.5 GHz signal. We can see this signal in the full span screen. We can set the start frequency to 7 GHz to speed up the scan process. Now we can see the 7.5 GHz signal is at the center frequency. We stop scanning the spectrum by pressing the stop button. We press down the left key of the mouse to draw a little square and then select the signal DF. The software will automatically open the DF screen. We select fixed frequency and press Run button again. We can see the signal's absolute and azimuth is 215 degrees, and the relative azimuth is 217 degrees. comparing to the vehicle's direction. Now, we change the horn antenna's direction, and we can see the changes of the azimuth accordingly. Now, we geolocate the signal. We change the horn antenna's direction to simulate the different places. We select the locate label. We press save button and save the current situation to the database. We change the horn antenna's direction and save the data again. Then we do one more time and save the data again. Let's press query and record the saved data. We select the right frequency and tick the 3 items. Then we press locate button. Then we can see a crossing point, meaning the location of the interference. We can use this button to erase the current location and start a new one. That's all. Thanks for watching.